Hi everybody, in this video let's look at 8.2 additions and subtractions of vectors. So in the previous video I told that a vector consists of two things, magnitudes and directions. So the length of the line tell you the magnitudes of the vectors and the arrow tell you the directions of the vectors. The resultant vectors, okay, now here we are talking about additions and subtractions of vectors, right? The resultant vectors of two non-parallel vectors can be obtained by the triangle law or the parallelogram law. Okay, if this is a vector A and this is a vector B, so where is the resultant vectors of vector A and B? It means A plus B. So A plus B will be over here. This is a resultant vector of A and B. A plus B. So you get here, you get this line. This is the resultant vectors, A plus B. So look at this one. OB equal to OA plus AB. This is a common point. OA plus AB, you will get OB. Okay, sometimes the diagram might draw for you differently. For example, this. Draw the A over here and B over here. So how do we get the resultant vector of A and B? You can use this parallelogram law or you can use the triangle law also. You will get exactly the same answer. Now, so if I want to use this parallelogram law, I transfer the B, the vector B over here. Draw a line, same length, same gradient, same direction. And then the OA, I move it up here, same length, same gradient, same directions. Now, the diagonal over here, the diagonal of the parallelogram, this line, will be the resultant vector of A and B. This is parallelogram law. So let's say if you don't want to use this law, you can also actually use the triangle law. You get exactly the same answer here. Okay, let me show you. So I want the resultant vector of vector A and B. It means that A plus B. So I just move the B over here. Now I got a triangle A plus B. So I know that the resultant vector of A and B will be over here. Okay? Okay, now let's look at this one. The resultant of three or more vectors can be obtained or can be determined by using the polygon law of vectors. If this is A, this is B, this is C, this is D, A plus B plus C plus D will be over here. This is the resultant vector of vector A, vector B, vector C, and vector D. Okay, so when you solve the questions for vectors, you have to look carefully the arrow. It's very important. Now let me explain to you this one. The subtractions. Just now we talk about plus, right? Now we talk about subtractions. The subtractions of two vectors is the additions of one of its negative vectors. Okay, for example, if I ask you to draw, okay, let me draw over here. If let's say I have a line, okay, let me test. If this is, oh, let me use the arrow. If this is A, let's say this is A, vector A, and then I have another vector which is vector B over here. Okay, let me label first. If this is vector A and this is vector B, so A plus B will be over here. So any problem for this? A plus B. So this is what we did just now. So this is a resultant vector of A and B. So how about if the question asks you to draw A minus B? How? So A minus B is actually equal to A plus negative B. So it means that we want to figure out what is a vector of negative b. So it's actually very easy. Negative b, it just means that opposite directions of b. So the b is going this way, right? Negative b will go backward like this. So let me draw an line for you. So this from here go 1, 2, 3, 4, 5, right? Let me check again. 1, 2, 3, 4, 5. 5 steps to your right. This is positive b. So if negative b, it will be 5 steps to your left. From here, go here. 1, 2, 3, 4, 5. Okay. So now this is negative b. So a plus negative b, it will be here. Okay? A minus b is the same thing as a plus negative b. Okay? So if you cannot understand, try to pause the video, try to think first. Oh, I forgot to draw an arrow here. So this is a minus b. This is a plus b. Okay, now let's try some questions. Okay, we want to draw PQ. PQ is equal to 3 over 4a plus 1 over 2b. So this is a, 1a, and this is 1b. So now let's figure out how to get 3 over 4a first. Okay, now let's focus on this vector a. Forget about the vector b first. Let me draw a triangle. So this how many steps? 1, 2, 3. Okay, let me calculate from here. 1, 2, 3, 4. 4. And this 1, 2, 3, 4. Right? Okay, since I want 3 over 4 only, I have to take this one times 3 over 4. Take this one times 3 over 4. Okay, so I will get 3, and here I will get 3 also. So it means that if I want to draw vectors 3 over 4a, then it will be 3 steps go to right, 3 steps go up, then it will be here. Okay, how about I draw it here? 3 steps to right, 3 steps go up. Okay, 3 steps. Let me use this line easy. 3 steps to the right hand side, then 3 steps go up. Okay, not same gradient, right? Okay, so now this is 3 over 4a. Let me label first. 3 over 4a. Okay, now we are going to figure out how to draw the 1 over 2b. So this one should be easier. Look carefully at the directions. B is over here. Now, how many steps? 1, 2, 3, 4. How many units? 1, 2, 3, 4, 5, 6. 6 units to the right hand side. If I want half only, you see positive, it means same direction, still going to your right hand side. I want half, so it will be 3 units, right? So it will be 3 units now. I'm going to draw a line from here to here, 3 units. Oh, let me check or not. So can I draw it here? Yes, you can, but for this, I would prefer to draw it here. 1, 2, 3, okay? So this is 1 over 2b. So this is 3 over 4a plus 1 over 2b. Then the resultant vectors, which is pq, will be over here. From here, go to here. Okay, so this is the resultant vectors. Oh, this is p and this is q. Okay, let me check around now. 1, 2, 3, 4, 5, 6. 1, 2, 3. 1 2 3 4 5 6 1 2 3. Okay, correct. So some student might think this way. So why can I draw this 1 over 2b over here? Yes, you can. Okay, let me show you how do we do that way. You will still get the same answer. Okay, so now let's say I want to draw the half of b, this one over here. Still the same, three step. Okay, so this is half of b. But be careful, we don't connect this way because this is not 3 over 4a plus 1 over 2b. This one we can use parallelogram law, right? So you remember. Now I draw this line, I transfer this line, go up here, 3 steps to the right hand side. Okay, then I transfer this line to here. So this is 3 1 2 3 1 2 3. Do the same thing, 1 2 3 1 2 3. So I draw this way. Okay, so this is 1 over 2b, and this is 4 over 3a. So the diagonal, which is here, from here to here, is the resultant vectors of 3 over 4a and 1 over 2b, which is pq. This is p, is q. Okay, you still get the same answer. 1 2 3 4 5 6 1 2 3. So this both will give you the same answer. The first method I show you triangle law. The second method I show you parallelogram law. It's up to you as long as you can get the resultant vector correctly. Okay, now let's try the second part B, hk. Now we have a negative vector, so we have to be more careful. Negative, it just means that opposite directions. Okay, now let's go to this 1 over 2a first. 1 over 2a, it means that half of this. This is 1 2 3 4 1 2 3 4 4 4. Half of it, it will become 2 2, right? So now I'm going to draw this vector. So I don't want to start from here. Why? Because I see this negative 2 over 3b. It means go this way. If I start from here, later on I worry that I don't have enough space. So how about I start from here? So this is 4 4. Since I want 1 over 2a, half only, it will become 2 2. Okay, I start from here. 2 2. Okay. So this is 1 over 2a. Now we go to this one. 1 over 2a minus 2 over 3b is actually the same thing as 1 over 2a plus negative 2 over 3b. So what we need to do is to try to figure out where's the vector of how to draw this vector, negative 2 over 3b. So this how many steps? 1 2, how many units? 1 2 3 4 5 6 units. Since I want 2 over 3, 6 times 2 over 3, so you get 4 units. But since you have a negative sign, so you know that it's 4 units to the, this is to the right. So we want negative, then it will be to the left. So go to left. 1 2 3 4. Okay. So this is negative 2 over 3b. So the resultant vector will be here. This is the resultant vector from here to here. Okay. So this h k, from h to k, this is 1 over 2a minus 2 over 3b. Okay, let me check, not 2, 2, 2, 2. Okay, correct. So this is the answer. So this is the way how we draw the resultant vector. Okay, now let's try this example 14. So I will always suggest you, when after you read the questions, you transfer all the important informations onto the diagram using a pencil, so it will be easier for you to solve the questions. We use pencil because if you write wrongly, it's very easy for you to erase it. Okay, the position vectors means that start from origin O, so the position vector of point A means from O to A. The position vectors of B means from origins to B, OB, okay, and so on, OC. Okay, this is OA is A, OB, okay, this line OB is B, and OC is C. So P is a midpoint, so this is a midpoint. Let me make a mark here, make a sign here, so that later on I know this is a midpoint. I don't have to go back to these questions. Find the position vectors of P and Q. We want to find P, it means OP. The position vector of P will be OP, and the position vector of Q will be OQ. So we have a few methods here. One is faster and the one is slower. So I will use this method to show you first. Now I'm looking for OP. OP means OA plus AP, right? OA plus AP. Okay, do you notice that this is a common point? OA plus AP, it will become OP. Now we are looking for OP. So do I have OA? Yes, I have OA. OA, which is equal to A. How about AP? I don't have AP, but I know that AP will be half, because this is one part, right? This is one part. And AP will be half of AB. So some students, they will just continue doing here. 1 over 2 AB. And then continue doing here. So I worry that you will a little bit confused this way. So I find AB over here first. Okay, I get the vectors for AB over here first, then later on only I write inside here, so it will not be so complicated. AB is equal to AO plus OB, right? So AO plus OB. Okay, again, this is a common point O. AO plus OB, it will become AB. Okay, now we have to look carefully the arrow. This is OA, pointing this way. The arrow is pointing this way from O to A, but now we are looking for AO, opposite way. So how do we write the vector? We copy the same thing, A, but this is opposite directions. We need to add a negative. Okay, then plus OB. OB will be no problem because same directions, O to B. The given vector also from O to B, right? So it will be minus A plus B. Now I transfer this whole thing over here. A plus 1 over 2 AB, which is this. Okay, so now this, you just do some expansion over here. Negative 1 over 2A plus 1 over 2B. So this is just like when you solve the algebraic expression. So these two are just like terms. This is A, so we can take 1 minus 1 over 2, you get 1 over 2A, then plus 1 over 2B. Okay, let me check my answer correct. Not 1 over 2A and 1 over 2B, correct. So this is the position vector of OP. So just now I told you that there is another method which is faster, right? But I will encourage you to use this method first at the beginning. So another method, you need to understand this formula. Okay, let me go back to the note to show you the formula. Okay, I think we'll be in the next page, right? Okay, wait for a while. Okay, Now, we are going to use this ratio theorem. If this is m, it means m part, this is n part. If you want to get these resultant vectors, I mean you want to get the position vectors of r, OR, it's very easy. OR is equal to MB plus NA over M plus N. This is the formula. Okay, now let's try use this formula to get the answer for the question just now I show you. Okay, wait for a while. Okay, so this is 1, this is 1. Why this is 1? Because midpoint, right? 1, 1. Now, I try to use the formula that I showed you just now, see whether we can get exactly the same answer or not. OP 1 times B, which is B, plus 1 times A, which is A, over 1 plus 1, which is 2. So you will get B plus A over 2. It's the same thing, right? 1 over 2B plus 1 over 2A, right? So normally we prefer to write the A in front. Then if you want to give this answer, also can, no problem. Okay, exactly the same answer. And this is faster. But at the beginning, I will suggest you to use this method. Okay? Now, let's try Q. So you can pause the video, try to find the position vector for Q. See whether you can get it correctly or not. Okay, now P is the midpoint of AB, so I write it here 1, 1. Oh, Q is the midpoint of BC. Same thing happened here. 1, 1, because Q is a midpoint, you can draw a sign like this. Okay, you can try to use the formula that I showed you just now, but here I won't use that formula. I will show you the longer step one. P, we want OQ. So first I write OQ first. I'm looking for OQ. So OQ will be equal to OC plus CQ, right? OC plus CQ. Okay, again, you have a common point over here, C. OC plus CQ, you will get OQ. Now, we have OC, right? Look carefully the directions. O to C, which is C. Okay. Now we want CQ. We don't have CQ. But I know CQ is half of CB, right? So same thing, I will find CB outside here first. Then later on, I plug in over here. So will not look so complicated. CB. Okay, so CB is equal to CO plus OB, right? Again, CO plus OB, you get CB. This is OC, but now we are looking for CO, opposite directions. So we need to add a negative. OB, no problem. We just follow the directions given here, O to B, which is equal to B. Now, I have CB. I'm going to move this whole thing over here. C plus 1 over 2 CB, which is here. So how about I write B minus C. Okay, so just do some expansion like just now we did. 1 over 2B minus 1 over 2C. Oh, now, so this is 1 minus 1 over 2. This 2 we cannot minus or we cannot plus because this is B, this is C, this is B, but these 2 we can. So 1 minus 1 over 2, you get 1 over 2 C plus 1 over 2 B. So normally I write to follow the sequence of the letters, so it will be 1 over 2 B plus 1 over 2 C. Okay, let me check. No, not 1 over 2. This is OQ. 1 over 2B plus 1 over 2C. Yes, correct. So this is a way how we get the position vectors of Q. Okay, let me write down first. Just now we got OP, O to P, which is equal to 1 over 2B plus 1 over 2C. And then this is OQ. So next thing, we want to get PQ. So how to get PQ? If this two we can get it correctly, this one should be no problem. PQ is equal to PO plus OQ, right? PO plus OQ, you get PQ. PO, be careful again, this is OP. What we are looking here is PO. It means opposite directions of this thing. So all the sign here we have to change. If negative, we need to change become positive. If positive, we need to change become negative. Okay, so not only we change this one also we need to change. So we have to write negative 1 over 2b. Okay, so here negative 1 over 2c. The reason I change the sign is because this is PO, this is OP, different directions, opposite direction. So OQ, no problem. OQ, this is OQ, right? We just copy this whole thing. So 1 over 2b plus 1 over 2, oh, no space. Let me erase this one first. 1 over 2b plus 1 over 2c. Okay, let me erase this one first. Okay, let me write again. 1 over 2b plus 1 over 2c, right? Okay, so you can start to simplify this one, minus this and this. If you want to rearrange, then you can do it this way. Okay, then negative. Don't forget this. We have a negative over here. Okay. Oh, maybe I make some mistake. Let me check. Oh, this is my mistake. OP. Just now we get OP is not 1 over 2b. This is A. Oh, sorry. This is A. 1 over 2a plus 1 over 2. I think I copied the wrong thing. Sorry. Not correct. So OP should be 1 over 2a plus 1 over 2b. So this one is not correct. Oh, this one, let me erase whole line first. Negative 1 over 2a, okay. Negative 1 over 2b, right? Okay, now, so this is negative 1 over 2b, this is positive 1 over 2b. Eventually, this two will actually cancel up. So the final answer will be negative 1 over 2a plus 1 over 2c. Okay, let me check again, correct or not. Negative 1 over 2a plus 1 over 2c. Yes, so this is the answer for this PQ. Okay, for this video I stop here first. Hopefully you understand better after watching this video, and remember, try to get some questions, try on your own. See you next time. Thanks for watching. Bye bye.